Good evening, everyone. In today's session, we are going to talk about priority queues, sir. Okay, priority queues. Priority queues. Sir, also, what is another name for this priority queues? Heaps. Priority queues are also called as what, sir? Heaps, heaps. Priority queues is also called as heaps, sir. Another name is nothing but heap. Okay, sir, let me provide introduction to this priority queue. Sir, very simple. What is the first point? It is also known as, okay, heaps. Another name is nothing but a priority queue. And these items are, okay, items are inserted at the end and removed from beginning, from the beginning, sir. So in the priority queues, always the deletion of elements will be always from the beginning. That is the key point what we have in our priority queues. And these priority queues is a logical ordering of objects. So based on some priority, that values will be stored, sir. For example sake, if you take the elements like 1 2 3, okay, and then if you insert a 5 and then 4, don't expect that the elements will be inserted like 1 2 3 4 5. So or so 5 4 3 2 1, like that these elements will be stored, means no, we can't give guarantee for that. It is completely based on the logical ordering. Of course, how these logical orderings are based on some priorities. So which one is having highest priority, which one is having least priority? So based on that priorities, the values are going to be stored and the values are going to be erased. Okay, so compulsory it is going to apply some priorities. Based on that only it is going to work. Okay, next, for example, so when we add an object, so into priority queue, sir, do you know reordering, reordering, reordering must be required, sir, compulsory. So after adding an object into the priority queue, you have to do reordering means what? In our technical term, it is called as heapify. In our technical term, it is called as heapify. Similarly, so when we remove an object from priority queue, sir, here also reordering must be required. So which is also called as heapify, sir, which is also called as heapify. That means what? When we are trying to insert the object or when we are trying to remove the object, compulsory there must be a disturbance in the heap that we have to resolve. That concept is called as what, sir? Heapify. Something like in our previous terminology, in the AVL trees we have seen, when we are inserting the elements, balance factor is not going to be happen. Okay, so in such cases what we are going to do, we will perform some kind of rotations, right? Same thing is going to be happened here also. Okay, sir, best example for this priority queue application is nothing but, sir, in the previous graph theory I covered Prim's algorithm. How this Prim's algorithm is introduced? Based on the priority queue only. Okay, we are going to identify the shortest lengths first. So how it is going to be happen? Based on this priority queue. And rank processing in the university, sir, student admission. So based on percentage. Okay, so like so many examples are there, like hospital bed allocation based on the severity of the disease. So all these things are best examples of our priority queues, sir. It is a different data structure, and this priority queues is implemented so based on heaps, sir. There is a heap data structure is there. Internally it is going to follow that. Okay. And compulsory it is implemented by using arrays only, because you can't use any like a class so to implement this, or linked list to implement this, because in the linked list continuation will be there. But so here we can't give guarantee, right? For example, first student, second student, third student, fourth student, fifth student. Assume fifth student got first rank. Then which student we have to process first? Fifth student. Next second rank, assume third student got. Next, which student we have to process? Third student. But in the link, so first student is there, then second, then third, then fourth, then fifth. Ordering is in the normal how you have inserted or how it is maintained in that order it is there. But our priority queue order is different, right? That's why you can't implement this. There is no proper format for this. That's why we are using some arrays. So I will explain how it is going to work. Based on that array concepts, we can able to implement this priority queues, sir. That we will see. That is our agenda. Main concept is that one only. I think yesterday also you people got confused because of this. Sir, now for your understanding purpose, I will take first predefined queue implementation. Predefined priority queues are already there. I will implement that priority queue, which is already defined in the Java. Then we will go for our own implementation. Sir, can you please confirm, is the introduction to priority queues, is it clear for everyone? I request every student to please respond. Friends, please confirm clear it is. Right, sir. Next. Next one. So predefined implementation of PQ. Already some priority queue is there. So how it is implemented? Directly I am taking program to demonstrate this. Sir, I will take 2 or 3 programs for you to understand. First example program, I want to sort. Okay, I want to sort the given integer values. I want to sort the given integer values. So based on ascending order, I want to sort. How we can able to do this? Let us take a Java program. So we have main method is there here. In this main method, I am going to take priority queue. Priority queue within bracket, I am taking integer PQ is equal to, so new priority queue. Like this I am taking. Yes, my priority queue is ready. Can I add the objects? Yes, by using add, we can add. First I am adding 3. So next I am going to add 4. Next I am going to add 1. So next PQ dot I am going to add 7. Like this I added some objects. Okay. Yes, correct, Vishal. Sir, we have added 4 objects. The structure is completely different, sir. Don't expect that this data will be stored in an ascending order. No, this data is not going to be stored in the ascending order. Sir, first the data will be stored. Assume this is the style what you have given, right? So it will convert this data such that the least element should come first. Like this we will have. Least element should come first. Like this we will have. If you access, we will get 1. We can't give guarantee that it is in ascending order. Assume here it is 14. It is not in ascending order. Next time when you are searching, this is the data 3, 4, sorry, 3, 14, 17, 7. In this, minimum element will come first. That means what? So 3, so 14, 7. Next time the element which you can able to access is 3. Next, among these two, 7 will come first. Then you have to access 7. So at last 14, have you observed every time at very beginning we are going to get a minimum element. Like this by default it is implemented in ascending. If you want a descending order, some other style is there. But in these integer values, the number which is minimum will come first. Have you observed? The number which is minimum will come first. Sir, we can implement in such a way that the student who secured maximum marks, I want to give first prize. Yes, you have to write code for that because it will default by default it will select the minimum value. That means the student who secured 0 marks will get a chance, but you have to override it. We have to override that we will see how we are going to do. Like this it will be there, sir. And make sure that you can't print this one. Even if you print this, you won't get in a proper manner. You won't get in a proper manner. Okay, sir, if you want to just have a look once, here I am trying to print that priority queue. Okay, here I'm trying to print that priority queue. Let us see how it will be. Have you observed? We got a 3. Now my requirement is, so I will take this pq dot add. I will take this pq dot add after 3. So now I want to check. So after adding this 4, what will be our result? 3, 4. Now I want to add 1. After adding this 1, I want to show you. So what is the result? Have you observed 1, 4, 3? Is it in order? No. If you observe, 1 came first because it is a minimum number. Then 4 and 13. Sir, after adding 7, I want to see the result. Sir, now see what will happen. 7 came at 10. Suppose if you are trying to add minus 7, then what will happen? Have you observed? That will be added at beginning. So we can't give guarantee for all the elements. That's why we can't print the objects by using, this priority queue directly. Sir, now I am taking. So until PQ is not empty. If it is not empty, try to get the top element so that it will be there in already order. PQ dot peak. Peak will return topmost element. Okay, topmost element. Then so pq dot try to remove that element. So top element so will be removed. Top element so will be removed means what? Sir, I can say in the place of top, can I take first? Yes, so first element will be removed. Like this we have. Sir, let us execute this code, friends. Have you observed? 1, 3, 4, 7, like that the elements got removed. Okay, I think how you can able to sort the values based on ascending order, you people got clarity. Sir, can I do this in descending order? So sort integer values so based on descending order using pq. Sir, how to do that? Example is same, sir. At the end, while creating priority queue, there is one collections predefined class is there. Sir, for this we have to take reverse order. Reverse order. That's all. Now what will happen? We are going to get the maximum element first. Okay, means what? It is in the descending order. Like this, we can evaluate and we can print the data in ascending order and descending order. Friends, can you please confirm, is the concept of sorting this data so based on priority queues? Is it clear for everyone, sir? Please confirm. Right, sir. Now my requirement is, can you take another example like a student? I want to sort the students based on okay, based on hall ticket number in ascending order. Sir, I want to ask the students, okay, for writing the examination. Okay, I asked the students to write the examination. So for that I want to prepare a roll number sheet room wise, in which room they have to sit. Like that I want to assign. Sir, based on assigning order of hall ticket numbers only the data will be there, right? Sir, now for this requirement I will take a class called student. In this student class, hall ticket number data is there and name is there. At the time of creating object itself, I will pass this hall ticket number and I will pass this name. Sir, now this dot hall ticket number will become hall ticket number. This dot name will become name. Like this I am giving. Anyway, we have to implement a public toString method. Okay, so public string toString method. If you print the objects, automatically it will print. In which format? Assume in between these square brackets, I want to take a current student hall ticket number followed by, so comma and gap, so plus so current student name. These two data I want to print. Yes, my student class is ready. So instead of adding these objects, sir, can I add student object? Yes, I am taking new student of, consider the student hall ticket number is 1 and the student name is nothing but something like Prakash. So next new student of hall ticket number is 4, name is nothing but Raju. So I want to take a new student, hall ticket number is 3. Okay, otherwise hall ticket number is 2, name is nothing but Kiran. Kiran. Okay. Next I am taking new student of hall ticket number is 3. I am going to take Karan. Karan, something like this. Okay. So PQ dot add of new student, hall ticket number is 9. Let us take Abhi, like this I am taking. Now observe carefully. I want to sort this data, sir. Okay. By default, how the data will be stored? Now listen carefully. We are going to get error. 1 minute. Which method? String. It is construct, right? Yeah. Because the name of the constructor should be same name as a class name. Have you observed? Student object cannot be converted into integer because here we have taken the type as integer. Now I have taken this one as a student. Of course, we will get error only. But when this error will come, when you are running the program, you are going to face the error. Let's run the code. So you can see here what error we are getting. Have you observed here? Java.lang.class cast exception. You can't convert this particular object because I can able to compare only comparable objects. But here you have not given any comparable objects. I was unable to compare. So that's why if you want to make this object as a comparable, maybe you have studied in your Java, we have to take implements. Okay, implements. So which interface we have to implement a comparable? In that comparable interface, there is one special method is there, like a public integer compare to method. You have to compare with another object, let it be student temp. So I'm going to return current object hall ticket number minus that temporary object hall ticket number. Okay. Suppose if you are giving first student hall ticket number as a 7. So second student hall ticket number as a 4. First student hall ticket number on S1 I am invoking. So 7 minus 4. What is the result? 3. So we are getting positive means what? First string is greater than second string. Which one is small? That will come first, sir. Like that, internally it is going to use this kind of sorting technique. Okay. Now can I expect the data in ascending order? Yes. Let us run the code and see the output. Sir, compare to object should be comparable. What is the problem here? Yeah, it should be, if you want to compare, that object should be of type student. Now you can see, sir, which object is coming first? 1 Prakash, then 2 Kiran, then 3 Karan, 4 Raju, 9 Abhi. based on hall ticket number ascending order. If I want to get the same thing based on, okay, if I want to get the same thing based on hall ticket number in descending order, now what we have to do? The program is the same, right? Same program you have to take, but the only modification what we have to do here is nothing but, so I want to sort, I want to sort, okay, the students, so based on their hall ticket number in descending order. Sir, program is the same. There is no change at all. So here at the time of writing priority queue, you need to take collection dot reverse order. Then automatically it will compare the data based on reverse order. Now the student who is having roll number as a highest value will get a chance first. So Abhi will get a chance, and then Raju, and then Karan, and then Kiran, something like this we are getting. Okay. So assume my room is like this. Okay. My room is like this. A big room is there, hall is there. So I want to ask the students to sit one by one according to roll number. Okay. Around assume some 100 members capacity is there. So faculty has given roll numbers like this 1, 2, 3, 4, like this. Sir, now once if the examination completed, I want to automate the system. So I need to display the hall ticket number on the screen. That student have to go first. Sir, will you give this one as a highest priority? No. Last bench. Next last one. Next last one. Like this we can give. Sir, in this display mechanism, which technique we are going to follow? This one only. Okay. Like this we can implement. Based on which priority? Based on hall ticket number in descending order. I think friends, so once if you execute this code, you are going to get the clarity. Okay. So I think you people got very clear clarity about how we are going to use these priority queues for comparable objects also. Can you please confirm? I think this concept clarified your doubts. Can you please confirm any doubts up to this, friends? I request everyone to please confirm. I request everyone to please respond, friends. Clear? Right, sir. Now, sir, we will do one thing. Now, I want to implement my own priority queue. Yes, it is possible. But if you want to do that, you should have a minimum idea about heap tree. Okay. So this is the problematic situation in the yesterday class. Sir, heap is nothing but it is a binary tree. It is nothing but a binary tree. Sir, what is mean by binary tree? At most, okay, at most two children should be there. Two children should be there. Next and after that, sir, it is a complete binary tree. It is a complete binary tree. Sir, what is mean by complete binary tree? Okay, sir, all levels, okay, all levels are completely filled. All levels are completely filled, maybe except last level, because shortage of nodes will be there. At the same time, that the filling should be done from left to right. So next last property, sir, heap order property it should follow. Heap order property it should follow. Sir, what is mean by heap order property? Very simple. The values which you have inserted, that the children values are there, right? Its children values should be always greater than or equal to parent values. Similarly, that the children values whatever you are going to store, sir, it should be always less than or equal to, okay, less than or equal to parent value. Two cases will be there. So this one, if the children values are higher when compared with parent classes, that parent values. That means what, root node will have minimum value, right? Then it is called as min heap, whatever we have seen in ascending order. Sir, if your children values are less, that means parent value is high, it is called as map heap, max heap, which is going to give the data in descending order. Sir, these three rules we have to observe while creating the heap. What is the first rule, sir? It is a binary tree. That means if you take any tree, sir, it should have at most two children. Sir, is it a binary tree? Yes. Sir, is it a binary tree? Yes. Sir, is it a binary tree? Yes. Sir, is it a binary tree? No, sir, because it is a tree, but it is not a binary tree. Binary tree means what? Zero children or one children or two children. That's all. Like AVL trees. Okay. So next term, sir, coming to this complete binary tree, all the levels are completely filled except the last level. Sir, can I take like this? Yes, there are two levels are there. In the first level, all the nodes are filled. In the second level, all the nodes are filled. Yes. Sir, can I take like this? First level is filled, second level only one node got filled. Yes, no problem. Sir, are completely filled except last level. Last level you can ignore. Sir, now I am taking a node like this. Sir, is it a complete binary tree? Yes, in the first level all nodes are filled. In the second level odd nodes are filled. Last level, maybe you can have relaxation. Sir, now can I take like this? Yes, you can say first level all nodes are there, second level all nodes are there, in the third levels also all nodes are there. At the same time, do you know that a filling should be done from left to right? Sir, now I have a tree like this. I have a tree like this. Okay. Now left node is there, right node is there. Its left node is the not there, but right node is there. It is not heap, sir, because first level okay, second level okay, third level also okay. But this is the first element. This is the second element. Where you have to take third element in the left right, because it is going to follow from left to right. First you have to insert the node to the left subtree, then you have to go for right subtree. But in this case, directly in the right subtree, okay, we have added. So that's why it is not going to follow this particular rule. I think you people got, okay, I think you people got clear clarity about how these two rules are applied. Can you please confirm if you are okay with these two rules? I will go with the next one, last one, heap order property. Can you please confirm everyone? Is it clear, friends? Right, sir. So next one, we have heap order property is there. What is the heap order property? Sir, if you take parent node, its value should be less when compared with its children. Sir, here I have 3 is there, here I have 2 is there. Sir, is its value is lesser? Is its value is lesser? Then it is called as min heap. Suppose if you are taking 7 here, and if you are taking 1 here, and if you are taking 2 here, sir, greater than 2, greater than 1, it is called as max heap. Sir, can I take 7 here, and here I am going to take 1, so here I am going to take 8? Is it correct? It is greater than 1, but it is less than 8, so one condition is not satisfied. So in this position, you can take, there are two possibilities are there for this. What is the first possibility? 1 can come here and 7 can come here, 8 will be there here. Or if you take 8 here, 1 should come here, 7 should come here. Have you observed? This is called as max heap and this is called as min heap. So if you are getting such type of things, we have to do heapify, right? This is the process what we are going to get. So whenever if you want to take a tree as a heap, then first property, it must be a binary tree. Second property, it must be a complete binary tree. So third property, so heap order property. I think these three rules, if any tree is following, then we can say it is heap tree, sir. Sir, okay, but how these nodes are arranged? If you take binary search tree, we know, so left side elements should be less than root, okay, and greater than right, like that we have some order. But how this tree is represented, that's what I told, we can't represent. Okay, so we can't represent, so heap trees, so in uh, class list format. So to overcome this, so we will use array concept, sir. How it is going to be represented in array, I will show you. Sir, observe carefully. I am taking a small tree for your understanding purpose. Consider this is nothing but a root node. Compulsory left child should be there and right child should be there. So for this, again, left child is there, right child is there. For this, left child is there and right child is there. And for this, again, left child is there. And you know the connections, right? So this is nothing but a connection like this. And this is another connection like this we have. Sir, what about the data? What about the data? So here we will have 8, consider, and here I am going to take a 5. So here I am going to take a 7, and here I am going to take 4, and so here I am going to take 1, and here I am going to take a 2, and here I am going to take a 6. Sir, here I am going to take 3. Sir, is it following our properties? Yes. What is the first property? It must be a binary tree. Means what? So 0 children, 1 or 2. For every node, for every subtree, we have 0 nodes or 1 node or 2 nodes. Okay. Second one, it should satisfy complete binary tree. Sir, complete binary tree means what? 1 node at first level, 2 nodes at a second level, 4 nodes at a third level. Sir, fifth node is incomplete, but left is already inserted. Remaining things are there. Okay, no problem. What is the third property? So heap order property. What is a heap order property? Root value. Sir, is it greater than 5? Yes. Is it greater than 7? Yes. Sir, is it greater than 4? Yes. Is it greater than 1? Yes. Is it greater than 4? Yes. Is it greater than 6? Yes. Is it greater than 3? Yes. So heap order property is also satisfied. So I can say this is nothing but a perfect heap, sir. But if I want to store the values, we need index concept, 0th location, first location, second location, third location, fourth location, fifth location, sixth location, seventh location. Sir, the data will be stored in the form of an array. Sir, how many elements will be there? Total 8 boxes will be there. So 1, 2, 3, 4, 5, 6, 7, and then 8. Total we have 8 boxes are there. But let me take values. Sir, here we will have 8. Next level node is 5. Next level node is 7. Next level node is 1 and then, sorry, 4, 1 and then 6 and then 3. And last we will have 2. Like this we have. Sir, what about the numbers? What about the index values? This is my main important concept here. So 0 is there. So 1 is there. 2, third location. So fourth location, fifth location, sixth location, seventh location. Like this we have. Now my requirement is, sir, please observe carefully. Suppose if you take, yeah, before moving to this, I think yesterday here only you people got confused. Can you please confirm everyone? Up to this, do you have any doubts, friends? Up to this, do you have any doubts, friends? Please confirm. Right. Now observe carefully. There is one standard formula is there, sir. What is that formula is? Sir, if you take any node, okay, if you take any node at x, sir, consider any node at position x. Sir, left node of this x will become 2 into x plus 1, 2x plus 1. Right of this particular node will become, sir, 2x plus 2. In this style, the data will be stored. If you want, you can see. Sir, here, let us take, sir, my first value. Okay, let us take my first value, I is equal to 0, because it is a root node, right? For this, I want to identify left. What is the formula? So 2i plus 1. Okay, sir, I value is 0. 0 into 2, 0. So plus 1, 1. And its right node is available in 2i plus 2. I value is 0. 2 into 0 will become 0. Plus 2 is nothing but 2. For 0, sir, who is the left node, sir? This one is nothing but left node. And for this node, who is the right child? It is nothing but 7. Next, let me take I is equal to. Sir, next I am considering this node. Okay. So I am considering this one. I is equal to 1. Sir, then your left will become 2 into I. So that is nothing but 2 plus 1, which is nothing but 3. And its right subtree will become 2 into 1, 2 plus 2, which is nothing but 4. That means for 1, sir, left subtree will become third location, right subtree will become fourth location. Is it correct? 4 and 1. Sir, this is left node, this is a right node. Now, sir, already for I is equal to 0, okay, 1, okay. For I is equal to 2, I am calculating. Sir, what is the left node? So 2 into 2, 4. 4 plus 1, which is nothing but 5. And right node will become, sir, 2 into 2, 4 plus 2, which is nothing but 6. That means when you are taking, okay, when you are taking I is equal to 2, sir, its left node will become fifth location. Sir, its right node will become in sixth location. Right. Now you have to take 4. This is the last node. I think for the remaining, we don't have any nodes. So now I am taking I is equal to, what is the next value? I is equal to 4. Sir, for fourth location, for fourth node, sir, what is the left node? So 4 into 2, that is nothing but 8. 8, sorry, 4 into 2, 8. 8, is it correct? I is equal to 3, right? Location I am talking. So I is equal to 3. I is equal to 3. So third location, left value will become 3 into 2. That is nothing but 6 plus 1, which is nothing but 7. Then right node will become 6 plus 2, which is nothing but 8. Sir, for node 3, third location value, sir, your left node will become which one? Seventh location. What about your right node? Sir, it is not there. It is not there. That's why, so whenever you are getting the value, you have to check if it is less than size or not. If it is less than size, you can continue. Otherwise, you can stop. So this representation we are using for performing heap operations. Okay, like how you can work with heap sort, but how internally this priority queue is going to work also, it depends on this particular strategy, sir. It depends on this particular strategy. I think, friends, you people got at least some idea about this structure. Can you please confirm how internally this heap tree is implemented? Is it clear for you people? Yeah, heap sort is not covered. After this heap only, we will do heap sort, because heap sort internally uses this heap trees. Okay, right, sir. Now this is nothing but what we have here, sir. Okay, fine. Next one, you know about min heap and max heap. I don't want to explain. In the min heap, root node must be smallest value, sir. And in the case of max heap, so root node will be there, right? That root node must be, okay, so larger value, that is maximum value. Now sir, I'm going to talk about insertion of an element into heap. This is very very important, sir. Yesterday majority of the students got confused in this area only. Sir, how to insert? Sir, very simple, sir. There are only two steps are there. Step one is nothing but add the element at the end. Add the element at the end. What is the second step? Sir, we have to fix the heap, sir. We have to fix the heap. How to fix the heap? How to fix the heap? Sir, maybe internally we are going to use some standard structure for doing this heap operation. Sir, what is that operation? Don't worry, we will do it manually. It is not heapify. Okay, we are not going to use any heapify. We will use manual algorithm only. Okay, we will use manual algorithm only. How you can able to do that? Okay, sir, it is a very simple process. Don't worry. First, I will explain the theoretical part, sir. Okay, normal approach, normal method. Observe carefully. Sir, now I am going to take diagrammatic representation. For our understanding purpose, I will take an existing priority queue. For example, consider I have a node is there like this. So this is nothing but a left subtree. This is nothing but right subtree. So this is nothing but it's left subtree, it's a right subtree, and it is left subtree. Like this we have. And links are nothing but like this. So this is nothing but what we have here. Let us consider the elements like 2, and this one is nothing but 3. Okay, and this one is nothing but we have 4, and this one is nothing but we have 5, and this one is nothing but consider 10, and this one is nothing but consider yeah, assume we don't have this node. Now I want to insert one, so into the node, sir. Okay, into the heap. Okay, so I want to insert this one into this heap, sir. Sir, now, sir, this is nothing but already satisfying some rules, right? And consider the locations. Sir, what about the locations? It is 0th location, first location, second location, so third location, fourth location. And what about the fifth location, sir? Sir, we are going to add always at the ending. Once if you add at the end, sir, where it will be stored? In this location it will be stored. In this location it will be stored. Sir, what is this location, sir? What is its ID? So here you can able to see this one will become 5. Sir, that's why I am not going to use any array, sir, because in array we can't give guarantee for the elements, right? So size, that's why I'm going to use some external data structure which is nothing but array list, where the size is not fixed. If you want you can add the objects, so if you want you can remove the objects. Okay, like this we have initially. So sorry. So initially, this is nothing but the content. Sir, what is the first object here? 2, because it is there at a 0th location. In the first location, we have 3 is there. In second location, 4 is there. So in third location, we have 5 is there. In fourth location, we have 10 is there. Now, recently, we added fifth location. So where the object is nothing but 1. So definitely it is not going to satisfy the property. Why? Because so the elements which is there in the root, it should be always greater than child node. But here child node is 1. Sir, is it less than this one? No, 1 is very less when compared with 4. Actually, where 1 should come? Here, then 4. Okay, of course, it is also not correct. That's why the node where you have inserted, try to get that index, which is nothing but last index, right? Try to get that index, which is nothing but last index, right? From that, try to calculate a parent index also. Try to calculate a parent index also. Sir, if I have a node X is there, we have formula. If you have a node X is there, how to identify its left subtree? Sir, for that 2x plus 1 is there. How to identify right subtree? Sir, for that we have 2x plus 2 is there. We have these standard formulas. Okay. Sir, now, yeah, correct. Suppose if I have a child node is there. So with value x. So I want to find out its parent. How you can able to find out its parent? Sir, x minus 1 by 2 you can take. This is the formula. This is first formula and this is the second formula what we have. Now identify here. Sir, here I have given I. So my I value is nothing but 5. Try to calculate parent index. What is its parent index, sir? 5 minus 1, 4 by 2, which will become 2. Yes, now we have these two indexes. Sir, try to compare the values. Try to compare the values. Sir, how you can able to compare? Very simple, sir. Is the child index value, is it less than parent index or not? Sir, what is the child index value? Here we got my child index value is nothing but 1, sir. Is it less than parent index value? Yes. Condition satisfied. Then what we have to do? We have to do swapping. Sir, which things we have to swap? Can you please swap? So fifth location, so and second location, these two. Sir, fifth location I am going to change to second location content, which is nothing but 4, and in the second location fifth location content. So here also this 4 is replaced with 1 and this 1 is replaced with 4. Sir, perfect. After this, what we have to do? Here one more operation at last. After completion of this, sir, before moving to the next step, what we have to do? Sir, your child index is there, right? Your child index will become, okay, parent index, and your parent index will become what, sir? Already we know the formula, right? That formula you have to apply. So what is that formula? So child index, so minus 1 divided by 2. So now what is the child index initially with this value? Parent index, that is nothing but a 2. So what is its parent index? Child index minus 1. 2 minus 1, 1. 1 by 2 means we are going to get 0. Correct, right? Sir, is this a child index value? In second location, we have 1. Is it less than parent index value? Yes. Then we have to swap this second location and 0th location. Sir, here 1 will come. Here we are going to get a 2. So here we will get 1. Here we are going to get a 2. Right. Now your child index will become parent index. And your parent index will become 0 minus 1 minus 1 by 2. Okay, which is nothing but 0 something like that. Sir, both are same, right? If both are not equal, then we have to repeat. So if both are equal, because here we are going to get 1 and 1, condition is false. It won't repeat this. So what is the updated tree that we got? 1 is there and its left child will become 3 and its right child will become 2. Okay. And its left child will become 5 and its right child will become 10 and its right child will become 5. Now observe carefully. Is it less than 5? Yes. Is it less than 10? Is it less than 5? Yes. Is it less than 3? Yes. Is it less than 2? Yes. It is satisfying my property. This property we have to check. Anyway, I will explain the code how you can able to do this. Okay. So I will explain the code how you can able to do this. Can you please confirm, is the right child of 2 is 4? Right child of 2 is 4, not 5. Oh, sorry. Sorry. Right. Sir, clear up to this? Can you please confirm? Can you please confirm? Is the concept is clear? Right, sir. So anyway, how you can convert this into program, that part I will explain tomorrow, sir. That part I will explain tomorrow. Okay. Right, sir. Thank you. We will meet for the continuation tomorrow. Tomorrow, I will finish this priority queues. Okay. Right. Thank you, guys.